Okay, in this class I want to talk about finding general solutions to trigonometric equations that have coefficients in the argument. I'm just going to look at one example, and that hopefully will be enough at this stage. So I want to find a general solution to this equation. It says sine of 2x is equal to negative 1/2. And we're going to follow the process. First of all, we're going to identify the quadrant and the reference angle, and then we are going to roughly sketch it and deduce our answers. Okay, remember the 2x is going to, change things slightly in this case. So the argument here is 2x, there's a coefficient of 2 in there. What are we going to do? Well, the first thing, I suppose, to identify the quadrant. So first of all, to say that sine of 2x is negative 1/2, and sine of 2x is negative if and only if 2x is in what quadrants? Well, you can see sine is positive in quadrants 1 and 2, so we're dealing with quadrants 3 and 4 here. So quadrant 3 and 4. Okay, we're going to identify the reference angle. First of all, if sine of 2x is equal to negative 1/2, well then sine of the reference angle is equal to positive 1/2, which of course means the reference angle must be 30 degrees. How do you find that? Well, you should know it. If you don't, then your calculator, you just type in sine inverse of 1/2. So, to draw my rough sketch, we're dealing with quadrants 3 and 4. Sine of 2x is negative 1/2, so the reference angle is 30 degrees. In quadrant 3, that'll be out there, 30 degrees. In quadrant 4, that's what that reference angle looks like. So here's the terminal side of our angle. Here's the terminal side of our angles. There will be infinitely many of them. So if I look at my solutions from quadrant 3, my first possible value for 2x is this angle in here. And I'm hoping you see that's through 90, 180, and then another 30. That's 210. So 2x could equal to 210 degrees. But any addition of 360 onto that will get me back to that same terminal side. So 2x is 210 degrees plus any multiple of 360. Remember where n is an integer, any integer multiple. In quadrant 4, my first time I'll hit that terminal side as I rotate around will be when I've hit around 330 degrees. So 2x, remember that's 2x, could be equal to, so I'm saying here that's 2x. So 2x could be equal to 30 degrees shy of 360. Well, that's 330 degrees. Whoop, I'm writing the wrong number down there. Apologies. 330 degrees. But again, any multiple, if I add any kind of multiple of a full circle, I'm back to the same terminal side. So 360 degrees times n, where n is an integer. Okay? So 2x is going to belong to the set containing 210 degrees plus multiples, any multiples of 360, and 330 degrees plus any multiple of 360. Again, where n is an integer. But crucially, we're not looking for 2x. When we're trying to solve this equation, we're looking for x. How do I find x? Well, to find x, I just divide everything in here by 2. So if 2x is 210 plus 360, well, dividing that by 2, x would have to be 105 degrees plus 360. That should say n. So 105 degrees plus half of 360, well, that's 180 degrees times n. And halving this one, 330 degrees, well, that's going to be 165 degrees plus 180 degrees times n. Okay? And that's how we solve, I should say, where n, of course, is an integer. So for any value of n, if you plug values of x into this equation, you plug values of x in here, any value of x where x is 105 plus some multiple of 180, You plug it in here into this equation, you'll find your answer is negative a half. So you plug it in here. Okay, so that's how we solve trigonometric equations generally, to find the general solutions for trigonometric equations that have coefficients in their arguments. Okay, so practice that. And that's end of chapter. So make sure you practice the revision exercises. Keep working.